This is our DSA final project, Starfishing. Our goal with this project was to find the shortest path between any two given actors based on whether or not two actors have starred in films together. So our data structure for this was a graph with actors as vertices and edges as whether or not two actors have starred in a film together. We also weigh the edges based on how many films two actors have shared. With Dykstra's, we have the option to favor actors who've shared more films together or actors who've shared few films together. Yeah.
Mhm. In terms of the UI and layout, it's the same as our sketch that we developed previously. At the top is our inputs, and they're heavily dependent on, they're very case sensitive on what's in IMDb. So if I were to put Jennifer Lawrence in all lowercase and George Clooney in all lowercase, it wouldn't find either actors. Similarly, if I just put one, it also wouldn't be able to compare because there's nothing to compare. But if I put them in uppercase, it generates a text that shows letter by letter, and it'll show the films shared by the year as well. Down below is a representation of the graph connecting all the actors together. Each time I click this button, it would generate the nodes being in different places at each time to kind of symbolize a star constellation, which would be like a play on words for starfishing. Um, and this scroll feature is also able to be used for the graph to be able to see it if it's too small. Um, the last visual element that like really sticks out is this starfy, which Hector helped me get together, and I rotated him to be able to kind of encourage you to keep going on your journey. If you clear, you get to wipe out all the typos or just run again, and it keeps generating a message to get you to play. So that's it for the UI.
In terms of the algorithms, I implemented the breadth first search algorithm and Julia implemented Dijkstra's. BFS finds the shortest path in a unweighted path and unrated graph. And in this case, the source slash starting node is the first actor that the user inputs. And it'll traverse through the rest of the graph until it reaches the target node, which is the second actor. And when it does, it will output the shortest path. Um, the dropdown selecting more or fewer films does not affect the BFS due to the algorithm not being affected by weight.
Dijkstra's shortest path algorithm is affected by weight. And the way it works is that it calculates the shortest path from the start node to any given vertice and then picks the shortest weighted path from those. And it will show actors with more films together or fewer films as desired.
And another thing to implement is, or to add is, if I'm in the middle of generating this text, I can just clear and start over again. And yeah, that's our project.